Good morning, ladies and gentlemen. It's my great pleasure to be with you in this virtual webinar that is organized by Technology Collaboration Program of Enhanced Oil Recovery by International Energy Agency on low salinity water flooding. This is Dr. Emad Al-Shalabi is speaking to you. I'm an assistant professor in the Petroleum Engineering Department at Khalifa University of Science and Technology in Abu Dhabi, United Arab Emirates. So today I'm going to share with you some of my expertise about low salinity water injection as a potential standalone to hybrid EOR technique. Starting with the outline of this presentation, first, I will be talking about motivations and objectives of this presentation. Then I'll be talking about some of the lab applications of this EOR technology in sandstones and carbonates. After that, I'll be talking about the controlling mechanisms for incremental oil recovery by this low salinity water injection technique. After that, we will go through some of the field applications of this technology in sandstones as well as carbonates. Afterwards, we will be talking about the hybrid applications of this technique. And at the end, I'll wrap up this presentation with some key takeaways. So starting with the motivations and objectives, well, we know that every reservoir go through three recovery stages. First, the primary recovery, which is mainly on depleting the natural energy of this reservoir. Then after that, we go through the secondary recovery, which is more or less based on pressure maintenance of the reservoir. And after that, we move to tertiary recovery methods, or what we call by enhanced oil recovery methods. So talking about water flooding as a technique, it has been used for years by field operators for pressure maintenance purposes, as well as for pushing the oil towards the producer wells. However, lately, field operators as well as researchers started paying attention to the chemistry of this injected water. And by that, I mean the total dissolved solids in there, TDS, as well as the ionic composition of that water, because this is expected to cause some oil, brine, and rock interactions, and this will be translated into additional oil recovery. And this is, ladies and gentlemen, what we term as low salinity or engineered water injection, which is under the others category of the tertiary recovery or in enhanced oil recovery methods. So let me talk about the difference between these two terms, low salinity or engineered water injection. Starting by low salinity water injection, we usually refer to this by diluting of the injected water. So we keep the amount of solute constants in here and we add more of the solvent. And this results in a total reduction in the total dissolved solids. Here is a schematic of the problem. Imagine that you have 8 particles of solute in 100 milliliter of a solvent. Then all what we do, we increase the solvent in there to about 200 milliliter, and that will change the concentration from 8% to 4%. So this is an example of dilution by low salinity water injection. Now, on the other hand, if I talk about engineered water injection, then here basically we refer to modifying the ionic composition of this injected water, and that's through hardening or softening of some key potential ions in the water. The engineered term basically is used to denote that proper screening is needed for coming up with what you can call your favorite recipe, cocktail of ions that will maximize the effect of rock and oil and brine interactions, and it will result in incremental oil. So this needs more screening compared to just diluting the water using low salinity water injection. Talking about the objective of this presentation, first we will highlight the potential of low salinity water injection technique. Then we'll discuss the importance of choosing the right water recipe, or what I call cocktail of ions. And then we will emphasize on the synergistic effect when combining this low salinity water injection technique with other enhanced oil recovery techniques. Talking about the lab applications of this low salinity water injection in sandstones and carbonates. Starting with sandstones, the technology was first introduced by Bernard in the 1960s, where he injected low salinity water to some of the cores that contains clay, and he witnessed the swelling of the clay. From that time, several researchers have done several extensive laboratory works, starting with Tang and Morrow in 1997 and afterwards. Al-Adasani and others in 2012 reported the positive impact of low salinity water injection in the secondary mode through 214 core floods, as well as in the tertiary mode through 188 core floods. And researchers basically observed that there should be an important factors controlling these mechanisms, like the clay presence is of importance, as well as the water salinity has to be within a certain range, usually between 1,000 and 5,000 ppm. I need to highlight that so far, most of the works that's been done in sandstones, they're mainly based on low salinity water injection or water dilution. Talking about carbonates on the other side, the start of trying this technology in carbonates was a bit delayed, and that's due to the effect I just mentioned, that they related this technology to the presence of a clay. And as carbonates, they have a minor clay composition to no clay, then researchers thought it will not have an effect. However, several researchers documented that the presence of some of the key ions, which we call them potentially determining ions, including mainly sulfate, calcium, and magnesium, will control low salinity effect in carbonates. Other researchers like Gupta and others in 2011, they said, well, it's not all about these three ions. Other ions will be important, like borate or even phosphate, or even if you just soften the water by removing the hardness of those calcium and magnesium ion, that will cause you more incremental oil. Some other researchers, they even witnessed a certain optimum concentration of that sulfate in order to maximize the effect of incremental oil recovery by this technology. However, here I need to stress on that we need to be careful with the use of sulfate ions, because that usually will cause scale formations and potential reservoir souring in our reservoirs. So I need to highlight that mainly the effects in carbonates were concentrated on engineered water injection, which is by ion manipulation through softening or spiking of some of those ions. However, low salinity water injection by dilution also was tried in carbonates, and here I'm just referring to a study that was done by Yusuf and others in 2011 in Saudi Aramco, where they basically injected seawater and they got a certain oil recovery. Here's like 70%. And then every time they were diluting the injected seawater, they were getting more incremental oil. For example, twice diluted, it will result in 7%, 10 times diluted, 9%, 20 times diluted, 1.6%, and then 100 times diluted, it reached to a plateau. So they documented an incremental oil recovery of about 18% out of using this technology in their core in lab scale. And that's mainly through low salinity water injection and through dilution. Talking about the controlling mechanisms for this incremental oil recovery by this technology. And here I'm summarizing one of those figures shared by Rotondi and others in 2014, where we see that the evolution in those mechanisms with time. So authors, they were referring to fine migration as a process, alkaline flooding, which is similar to what is happening with surfactant injection, multi-ion exchange, salting in effect, mineral dissolution, pH induced wettability change, and water microdispersion. In general, there is no still clear idea about what is happening and what is controlling the incremental oil recovery. But most of the researchers more or less agree on wettability alteration as one of those main controlling phenomena. Here in sandstones, if we talk about the mechanisms, I'll stress on multi-ion exchange mechanism, which is controlling wettability alteration. So in sandstones, we have clays that they're negatively charged, and we have the oil with its carboxylated groups that is negatively charged. And usually we have a positively charged ions that they're working as a bridge between these two negatively charged groups. So what is happening with the injection of low salinity water injection, we're basically breaking those bridges, and that will cause a release of the oil and more incremental oil. However, if we need to talk about the wettability alteration mechanism in sandstones, then there should be several factors that they lead to this incremental oil. Presence of a clay is important. Oil composition, and especially having that total acid number, becomes important. Formation water should be rich in divalent ions, magnesium and calcium. And low salinity water injection level, as what I said previously, it should be between 1,000 to 5,000 ppm. Also, the initial reservoir wettability plays a role. Usually, the greatest effects were pronounced for oil wet or mixed wet reservoirs. And lastly, high SOR saturation in the reservoir after high salinity water flooding needs to be there. Well, this in order to have more pronounced effect of the technology, as well as justify the economics of the project. Talking about the mechanisms for carbonate, well, again, wettability alteration is there. However, here, as what I said before, we believe that there should be some key ions that cause this wettability alteration, and I'm referring here to sulfate, calcium, and magnesium. The higher the concentration of those at higher temperatures, the more pronounced the effect. And usually most of the researchers also agree on the multi-ion exchange mechanism, but this happens differently than those in sandstones. So here I'm referring to one of those mechanisms. So basically, we believe that carbonate reservoirs at reservoir conditions, they're usually positively charged, or they have positively charged sites. And then the negatively charged oil carboxylated group will be sticking to that. Now, thanks to having sulfate in the water, which has a great affinity to the carbonate rock surface, as it has a negatively charged, then it will get close to the positively charged carbonate surface, and that will stimulate a repulsion between the sulfate and the negatively charged carboxylated group. Then thanks for the presence of calcium and magnesium, which they will form complexes with that carboxylated group, and they will release it to the surface, which results in more incremental oil. Talking about some of the field applications in sandstones and carbonates, here I'm showing a summary where several pilots of low salinity water injection have been applied to different parts of the world. So we can see some of them there here in the Middle East, in Russia, in North and West Africa. We can see some in Europe, and also in the North American continent. And I need here to stress on that most of those projects were mainly targeting sandstone reservoirs. However, we have some recent pilots in carbonates, and here I'm just highlighting two of them. Here I'm referring to the study made by Lager and others in 2007. Well, they looked into 18 of those field scale pilots, and they reported the incremental oil. And you can see on an average where we have about 14 to 15% of incremental oil recovery using this technology. As a study case, I took the case in the Endicott field in Alaska, where they were started basically with the 3 single well chemical tracer tests. And here I'm summarizing some of their observations for those 3 tests. So we can see that for the 3 tests, whenever they inject the high salinity water, then they dropped it to low salinity water, in this case about 1500 ppm. Then they see a reduction, a pronounced reduction in residual oil saturation. So for the first test, that was about 9 saturation units of reduction, and the second one about 11, and the third one about 17. So that was a great incentive for them to go ahead and implement the first interwell application. where they used one injector and one producer that they're about 1,000 feet apart. So what they have done, as you can see here in the graph, seawater has been there for a while, and then as soon as they started their low salinity water injection, then 3 months later, you see the effect on oil rate. So oil rate was a certain level, then as a result of injecting low salinity, it has increased. And they reported an incremental original oil in place in about 12%. Then they started basically looking into what could be the reason that is controlling the incremental oil, and is there a relation between these different tests, the ones that they have done at their core in the lab, and the 3 single well chemical tracer tests, as well as the interwell test. So what they have done, they have correlated the incremental amount of oil with the clay content that is there in each one of those experiments, whether they're in the lab or field scale experiments. And what we can see here clearly is with increasing the clay content in their rock, then you can see a higher incremental oil recovery. So the incremental oil recovery has something to do with the clay content. And later they even confirmed that by measuring some effluent iron concentration at the field level. And this iron is expected it has been produced basically by the ion exchange reactions that is happening at the surface of the clay. So that basically kind of supported their observation. We should not forget the first full field commercial application of low salinity water injection that is currently taking place in the Clare Ridge field in UK, and it started in 2017. So basically, they have reported so far a 7% incremental oil compared to conventional water flooding at a cost of just $3 per barrel for the development, which is really encouraging for the application of this technique, especially if you have already water flooding surface facilities there in place, then there is not much that you can add in order to have your low salinity effect. Talking about the carbonates, as I said earlier, there are just very few pilots, but there are way more coming in the pipeline. So here I'm reporting one of the first application in carbonates, which was done in Saudi Arabia, and that was in the form of 2 single well chemical tracer tests. So what they have done, basically, they have injected a high salinity water followed by a low salinity water, about 10 times dilution, and they reported about 7% reduction in residual oil saturation to conventional water flooding, which is basically a pronounced effect, and it shows that low salinity effect is there. And I need to highlight that here what they have applied is just as what you can see here, dilution of the water. The question is that are there any other applications or hybrid applications of low salinity water injection? And the answer is yes. And that's basically a good news for field operators that they do not believe in the sole effect of low salinity water injection by itself. Then combining this technology with other EOR techniques, then it will bring positive aspect on your enhanced oil recovery. Here I'm showing some of those hybrid applications of low salinity that has been proven at the lab scale. First, low salinity water injection and polymer flooding. So basically, once you reduce the salinity of the water, then you need less chemicals, less polymer to meet your target viscosity. And that really reflects positive in your CAPEX and OPEX requirement, as well as you have a better microscopic and volumetric sweep efficiencies. Another application, which is the hybrid low salinity water injection with surfactant flooding. With low salinity, usually some of those released oil blobs might be retrapped again because capillary pressure is still active. But thanks for the use of surfactant, which basically kills that capillary pressure, and it will help in producing more of the oil. Also, we should not forget the positive effect of low salinity in reducing surfactant retention. A third application for the hybrid effect is low salinity water injection along with gas or CO2 injection, where reducing the salinity of the injected water will cause more CO2 gas to be dissolved in the oil. And it has been reported that in this case, low salinity will boost oil recovery rate, while CO2, especially if it's miscible, that will control mainly the reduction in residual oil saturation. And there are several applications that they are in progress now in the lab, but I just decided to share some of the main ones in here. Also, for the field applications, I need to highlight that low salinity water injection and polymer has been applied at the field scale, and that's in the Greater Bergen Sandstone field, which is in Kuwait. And here I'm showing basically the production of this field with time, and we're up to 2010. Once the water cut started increasing, then they decided to apply low salinity water injection. And the way they have done it basically as a series of 3 single well chemical tracer tests, one with the seawater or formation water, and then one with low salinity water, and the third one which a combined or hybrid low salinity water and polymer injection. And they reported basically 7% reduction in conventional residual oil due to this hybrid technique. Some of the main key takeaways at the end of this talk, I want to highlight that low salinity water injection has a high potential as a standalone, as well as a hybrid enhanced oil recovery technique. Also, I need to say that wettability alteration is believed to be the main reason for incremental oil recovery by this technology. A very important thing to stress on is that the improvement in oil recovery using this technology is really a case dependent, and you need to make sure you understand those factors before you have any pronounced effect. And those factors are the temperature, the pressure, the rock mineralogy and initial wettability state, the oil composition, and most importantly, the water composition. I hope you enjoyed this talk, and I look forward to your questions. Thank you and stay safe.